Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with episode 232 of Ask Dave. Today's video covers the erection of the BigIR antenna from SteppIR. And I did one video previously that kind of introduced the concept to it. Basically what it does is it has a beryllium copper tape, think of it as though it were a measuring tape. It feeds it up into a pipe, and the longer it gets, the lower the frequency that it will become a vertical antenna on. So this video covers the erection and some initial testing of the antenna. The erection took Brad Rich, for whom I give a great big shout out. Also, my wife was helping, and the photographer or videographer is Lauren Cook, my assistant, whom you'll all meet, I'm sure, in a future video. So we're going to go through the erection of the antenna, then we're going to go through some initial testing, and then I'll have a few words at the end. So let's go. Let's put it up. First, we laid out the pieces. The white tube is the inner tube. The first thing that we have to do is put these outer tubes, which are real stiff fiberglass, over the inner tube, which is a plastic. The reason for the small tube is that the beryllium copper tape goes up inside of the little tube. The big fiberglass tube is too big, and it's possible to get the tape bent. So that's the first piece in place right there.
There's no clamp?
Of course, we consult the manual, which is not always entirely clear as to what goes where. Fortunately, Brad has done this before, so he has it all figured out.
We ended up putting a boot on there.
SteppIR makes a very secure pole. Not only do the pieces fit into each other, but there's also heat shrink tubing and O-rings to keep the water out.
On that.
We used the kitchen table as a place to store parts. It made it easy to just step inside the house and pick up what we needed. Here we continue putting on the outer tubing, which provides strength and weather resistance. The white inner tubing pieces are glued together. The O-rings are put on to help with the water seal. The joints in the outer pipe are sealed not only with O-rings, but with heat shrink tubing that has a glue on the inner surface. Brad uses a heat gun to shrink the tubing. Considering it was near freezing outside, it took a bit of work to get the heat gun to work well. The top of the outer pole is a tapered piece of green plastic, which Brad is unwrapping and putting in place. Again, heat shrink tubing is used over the joints. The last piece of heat shrink tubing requires a great deal of shrinking, but we get there. The rubber boot is placed over the joint between the gray fiberglass poles and the center green upper section. This is screwed in place with hose clamps. Overall, the antenna goes to great lengths to create a benign environment for the metal tape. We put the guy attachments in place. As it turns out, we got them slightly wrong.
Yes.
We should have turned one element so it faced the other way. There are two guy attachments, one just a few feet above the other. We opted to guy with both of them. Here we put the cover over the EHU. It was not clear from the instructions which bolt went where, so we had to do lots of experimentation.
I'll go find.
These are nuts with nylon keepers which will stay in place permanently, but they sure are a pain to put on. Here we are putting on the 80-meter coil attachment. Note that I have already attached the control line. The control line is also in place for the EHU. Our guy rope is simple parachute line purchased at Home Depot. It goes to prove that you cannot go through an entire project without making at least one trip to Home Depot or Lowe's. Since the rope was so inexpensive, we bought 6, so there would be a roll for each guy. We will stretch these out once we have the antenna in position. Here I attach guy ropes to the other guy point. There's a total of 6. This is documentary proof that I am a lousy knot maker. We make final preparations for putting up the antenna. Note that the control cables are already attached. I used a piece of duct tape to hook them to the antenna so that they would not tear off. We move the antenna off the porch and in the direction where it will be mounted. My wife jumps in to help. We move the antenna to the clearing where it will be erected.
Up. That end's going to have to come down.
We're going to mount it using the same pole buried in the ground that I used for the butternut. I had to create an adapter to go down into the 22-inch deep hole and extend up above the ground enough to mount the new antenna. The clearing is not big enough to lay the entire antenna down. So as we went into the clearing, we had to raise the antenna and finally slip it over the pipe that comes up out of the hole. After some wiggling around, we dropped the antenna on top of the pipe. Brad holds it while Loretta and I start to attach the guys to nearby trees. On the ground are the new radials that came with the antenna, made of green wire. We opted not to attach them yet. There are lots of radials left over from the butternut, which we will use for initial testing. There is a boot that goes on the bottom, which Brad attaches. There is still a coil attached to the radial plate, which Brad will detach. That coil goes with the old butternut.
Yeah.
Ouch. Oh,
No.
you got
Sap.
sap. That's too bad.
Sap.
Sticky, sticky stuff.
Don't you have some
I have goo gone.
Oh, yuck.
Okay.
All of the existing radials are attached to the DX Engineering radial plate. We move it up a bit so that it is closer to the EHU housing. Here we get it all connected up so that it is close to the antenna's bottom. The next step is to ground the antenna itself to the radial plate. Brad opted to use a piece of copper strap to do this. Of course, nothing is simple when you're doing it out in the field, but Brad conquered and put the strap in place. We opted to install a ground rod at the antenna. There's already a ground for the radials, but it's composed of bare wire laid about 6 inches below the surface. We thought we should have a ground rod right here. He has a fancy tool for driving ground rods, which he uses here. It turns out we were able to get the ground rod in using this little attachment about halfway, and then the rest of the way by using the tool directly on the ground rod. I was about to cut a piece of LMR 400 to make a new cable for the antenna, but Brad had brought with him a roll of comparable Messi and Paolini coax and wanted to try it out. The Messi and Paolini coax is made in Italy and is imported by MFJ. It's really nice coax. They have a different way of putting on connectors. There is a video on the Messi and Paolini website that talks about how to do this. So after measuring out the coax, we brought it all into my shack and I put the connectors on. I speeded this up so that you can see what it looks like. Messi and Paolini have a special pair of scissors to do this job. I'll have to get one. But we got to it. Everything was tested, and we took the cable outside to install. We ran the cable from the antenna to my lightning protectors. I only have 6, so I unscrewed the MFJ octopus to make room to attach this here. Here I attach the cable. I'm going to have to replace all this mess with something in a box because the grass keeps growing up around this. I use a pair of lineman pliers to tighten up the connection. Well, it took an entire day for Brad and I to get the thing put up, and we did have some time for initial testing, which was extremely encouraging. I've got a little bit more thorough testing with some from each band here, and let's take a look at what that is. Please note that the antenna can be calibrated, okay? So if we see it off a little bit, we can tweak it so that it will come up to the right length for each frequency. This testing is done as is out of the box, okay? Some of the bands are quite impressive. Others are going to need a little calibrating. I'm using the existing leftover radials from the butternut antenna, my old butternut HF9V that used to be in that location and now is laid apart in another part of the property. There are about 24 radials there of various lengths. Now, the BigIR comes with a radial kit, okay, that provides 12 more, and I will install that on a day without snow, okay? Right now, everything's covered with snow. And hopefully it won't be like last year when the entire winter, the ground was covered in snow. This year, I'm hoping for a few clear days. And I am noting here that I am using the 80 meter coil. First we look at 80 meters. Now if you look at the V curve over here, you'll note that the bandwidth of that, this is the entire 80 meter ham band here, it's covered with a very sharp V, but notice that that's about 1.12 at 3.82. Now the thing thinks it's talking at 3.7. So you can see that with a little calibration, just getting these frequencies to line up, that whatever frequency we tune to in the 80 meter band will have an excellent SWR. And that's great, because I'll have an antenna that covers the entire 80 meter band. And it will, once I connect it to the transceiver, it will just automatically go to the right frequency. Looking at 60 meters, this is again out of the box. We're trying for 5.37 here, and that's right there, okay? And we see that the minimum is over here, but notice that it's about 1.4, okay, 1.37 at a lower frequency, so that's easily calibrated. We'll take care of that. Here's 40 meters, and it's excellent all the way across the band. It says 7250, it's actually 7175, but now as we move up in bands, it's well below 2 to 1 everywhere on the band. 1.5 is not a bad SWR for an antenna like this, and the tuner in the radio can take care of that last little bit. Now on 30 meters, we do quite well. Notice that it's nearly flat all the way across. 1.49, essentially across the band. Again, the tuner in the radio can tweak that out. That's just fine. I won't need to do any calibrating on 30 meters. 20 meters, again, apologize for the fuzzy one here. We're under 1.5 to 1 over most of the band. This thing is set for in the CW band, and our minimum 1.23 at 14.040, which is right here. 14.070 is right there, so it's pretty good. If you were to tell the controller to go up in frequency, it would take that curve with it. But I am going to tweak it just a little bit. Now we have 17 meters, okay? 17 meters is 18 megahertz, and again, 1.5 to 1 across the antenna. Now, note that it does come down a little bit here, so I'm going to tweak it just a little bit, see if I can get that drop right in the middle of the 17 meter band. Now, in 15 meters, at its normal quarter wave length, we get about 1.5 to 1 across the entire band. And 15 meters is a pretty good sized band, so I'm impressed with that. But also, this is the first band where you can use, instead of a quarter lambda, you can use 3/4 of a lambda. And here's what it looks like for that. First of all, you push in the BI button, BI. It pushes the thing up to 3/4 of the wavelength, and that light comes on. Here we see that there's a dip over here somewhere, so we can move that dip this way by the calibrating of the antenna and get an excellent SWR across the band. Plus, at 3/4, the antenna is substantially longer. Instead of a quarter wavelength on 15 meters, it is 3/4 of a wavelength. Okay, so here is now 12 meters, and it's 1.5 to 1, which is great across the band. Now we go to the 3/4 section by pushing the buy button, and it comes way down. Look at that, 1.2 to 1 and below across the entire band. It's got something lurking out here, which we can pull in this way and have that thing really cool. On 10 meters, just normal quarter wavelength, 28.59. Most of the activity in the band is found around here, so that's not too bad. But we can move that around if we want to a little bit. When we go to the 3/4, we get a somewhat sharper curve. It actually goes up above 2 to 1 here. Could be taken care of by most tuners and most rigs without a problem. But we can move this where we want it. This right here, 28.3 to 28.5 is kind of where you find a lot of the activity. But we want that, see it says 500 there, and we want that to agree with where the dip really is. Now on 6 meters, they apparently only do 3/4 lambda. And this one needs some tweaking. We see we're okay down over here somewhere, so we need to move that way, which we will in the calibration. So overall, the test results look very encouraging. I'm very pleased by the amount of control that we have here. Well, we were all pretty tired when that was over. It was a full day getting that thing up in the air. And the test results I took this morning, so they're current, even though we have about 6 inches of snow on the ground right now. So the next video is going to cover the operation, calibration, and use of the antenna and show how well it does on the air. And I'm going to compare it to the MFJ hex beam, which I have, and see how well it does. It should do very well. I'm very excited about this antenna. It's quite a good antenna. Please be sure to check out dcasler.com/support for different ways that you can support this channel financially. Every little bit you give helps. Now remember, everything I've got on here is for free. You're under no obligation to do anything, nor should you feel guilty if you can't or don't want to or whatever. But if you can, it's greatly appreciated. I appreciate it very much. There's several things that you can do. You can either go in Patreon, you can do something in the tip jar, you can set up a monthly subscription for $5, $10, or $20 on PayPal. There's also video drives available for Extra and Technician. Now, in a big announcement that's coming up here, I am getting those general videos in shape. If you go to www.ke0og.net/general, you'll see all that's been done so far to bring things up to date for the general videos. The rest of the stuff that's up there are videos I need to make from scratch. So those will take just a little bit longer, but as soon as they are done, you'll be able to get the general videos on a thumb drive if that works better for you. Most people just study it right on YouTube. For some people, that's a little bit harder to do because they don't have Wi-Fi, or they're in a subway or a bus or something like that. So whatever works best for you. Thank you so much for being a subscriber of Ham Radio Answers. If you are not a subscriber, please do so. As soon as you become a subscriber, you're an Augie. Until we next meet, 73.